So looking at the first part, we've talked about what a midpoint is. What's a midpoint? From last class, how do we define it? It's a point on a segment that is, what's the word we used? They're equal, right? But there was a word that we used. They're the same distance, right? Equidistance. Remember, we used the word equidistance, and again, you have this on your notes from when we defined it in class last time. Equidistant from both what? Equidistant from both what? Endpoints. Good. It's equidistant from both midpoints. So if we simply take the 2 points that were given here on the first example, notice we have R given to us, we have S given to us. So what we needed to do is find what is the point exactly between those two, or the midpoint. And how did we define that? What formula did we use to define that last time? What was our formula? The midpoint is equal to what plus what? A plus B divided by 2. A plus B divided by 2. All right. So A, our first point there is -2. I'm going to add 9 to that and divide it by 2. So what's -2 plus 9? 7, good. Divided by 2. We could leave it as that, or that's the same thing as 3.5. And if we check that, let's plot 3.5, so exactly between 3 and 4. And you can tell that is the midpoint between the two lines. And again, using our definition, the midpoint again means it had to be the same distance from both. So if I go from 9, I went 1, 2, 3, 4, 5, and then half another one. Do the same thing over here. 1, 2, 3, 4, 5, and then half another one, and we end up at that point. All right. So that's how we define midpoint, and that's what we talked about yesterday and on Friday. Yes, ma'am.
I'm kind of confused.
Okay.
Like the red marks, why do you have to do that?
All I did there is just showing you that our units that we counted were the same. I went 5.5 here and 5.5 here, so that's why this was midway. Because remember, our formula said it's the same distance from both endpoints. So all I did here with those red marks is just show you that it was the same distance from both endpoints. All right, just to show you that it lined up. Because if I only went 4 one way and 5 the other, it wouldn't have been exactly in the middle, so it wouldn't have been the midpoint. All right, example 2. Notice we start seeing these a different way now. Now we're looking at midpoint a little bit different. It's not just being defined as a point or a set of coordinates, but now it's being defined as an expression that has some variable inside of it. For example, B is the midpoint of AC. So let's draw a segment there. Here's our line segment. Okay. It says B is the midpoint, so we have B here in the middle. It's hard to see that. I'll change it. So B is in the middle. A is one endpoint. And C is the other midpoint. Right. So we have two distances here. We have AB here. What's the length of AB? The length of AB is z plus 2. Then we also have BC given to us as 2z minus 6. And what has to be true about these two line segments? What's true about z plus 2 and 2z minus 6? They're equal to each other. Right? Because B is the midpoint, meaning it's in the middle. If it's in the middle, then they're both equal. So I'm simply going to add the two together. I mean, they're equal, sorry. Set them equal to each other. So if I've got z here, 2z minus 6 on the other side, what am I going to do here to solve this for z? What's the first step? We won't divide first. Remember, we won't divide until we have everything away from the z. So you combine your like terms. So we're going to put all the like terms on the same sides. So we'll move the 2z from the right to the left. Now you could have moved the z to the right side, but let's get in the habit of moving it to the left, because when we start talking about inequalities, if you're putting your variable on the right, it makes it kind of confusing when you go to graphing them. All right? So let's just get in the habit of putting your variable on the left side. So subtract 2z, so I'm going to have negative z plus 2 equals negative 6. Now what? Subtract your 2, good. So negative z is negative 8. So what's positive z? Positive z, therefore, is positive 8. And make sure you check your work, guys. All right? Make sure you check it. The way we check it is because I know if I put this z here, this 8, in place of z both here and in place of it here, if I do that, I'm going to have the same thing. All right? So substituting that in, I've got 8 plus 2, which is 10. Right? We take our equation there for line segment AB. And then if we take line segment BC here, 2z minus 6, so that means 2 times 8 minus 6, which is 16 minus 6, which also is 10. Right? So I had 10 on both of those, so it worked. If I didn't have 10 on both of those, then that would mean that B was not actually the midpoint, or it would mean that my answer I got for z was incorrect. All right, if you look at example 3 real quick, just because that comes from what we've covered the last couple of days, if you'll look at it and answer it using the same thing that we did before. Remember, when we have coordinates like that, the midpoint is simply defined as the midpoint of the x's and the midpoint of the y's. That gives us our ordered pair there. Now, real quickly, as you're working on that, before I forget to tell you, let me go through the announcements real quick, because there's an important thing about Thursday on there. It says Thursday's the district ride pep rally at 9 o'clock. Highlighted, big letters, all students must ride one of the buses to the football stadium. So you cannot ride your own vehicle, guys. If you have late arrival, make sure you're at the high school prior to 8:30 to get transported to the football field. If you have late arrival and do not want to go to the pep rally, report to school at regular time, and you'll need to check in at the front office until the pep rally is over. And again, in red, no students are allowed to take a personal vehicle to the stadium on Thursday for the pep rally. Every high school student must ride a bus to and from the stadium. All right. Now, anyone who's wanted to do one-act play, if you want to be one of the actors or stage manager, lighting, any way, shape, or form, if you want to be involved, make sure you see Ms. Brazel in room D208 to sign up as soon as possible. Also, don't forget FCA is every Friday morning, guys. It's at First Methodist Church here in town at 7 a.m. They will bring transportation to get you from there back to the school. So for our example 3, -2 and 3 are our x values. So what is the midpoint of the x's? What was the midpoint? So we take our two x's, -2 plus 3, and then we divide by 2. Again, that's off the notes. That's all that we did on Friday, and that's what your assignment was over yesterday. So -2 plus 3 is what? 1. So I'm left with 1. I've still got the 2 on the bottom. Same thing with the y's. 4 plus 1. Divide that by 2. So you get 5 over 2. So 1/2 and 5/2 make up your midpoint of line segment EF.
That's the answer?
Uh-huh. Simply just take the x's, add them, divide by 2. Take the y's, add them, divide by 2. That's your x and your y coordinate for your midpoint. Now, if you look at example 4, does anybody still need that up there? All right. Looking at example 4, this one it says that M is the midpoint of AB. A is 3, 5. M is -2, 1. Therefore, what we want to do is find out what is the midpoint. Okay. Simply find the midpoint. Now, get in the habit of writing them down. I know coordinate A is 3, 5. I know I always need the midpoint, and I need some coordinate B. So I know 3, 5. I know that the midpoint is -2, 1. Midpoint is -2, 1. Ladies, make sure you're paying attention to this instead of talking. Now, from our definition today, and as we talked about last time, a midpoint is a point on a segment that is the same distance, equidistant, the same distance from both endpoints. So look here. M, the distance then, if we use that, between A and M, has to be the same when we go from M to B, if it's the midpoint. So how much do I go from 3 to -2? I go down 5, right? Which means I have to go down 5 here, if it's the midpoint. So what's -2 take away 5 more? -7, good. So I do the same thing here. 5 to 1 is down 4. So what's my y value for my B endpoint? -3. Again, because if I went down 4 there, I had to go down 4 here as well. Now, the next thing we're going to talk about is what a segment bisector is. Now, a segment bisector is really the same thing that we've talked about so far, except for a midpoint is just a point. A segment bisector can be a point, It can be a line, or it can be a plane that intersects a what? Intersects a segment at its what? Intersects a segment at the, what word is it that we've been talking about? The midpoint. Good.
What is it, midpoint?
Uh-huh. So now instead of just a point being there on it, it can be a line or a plane. Now, a line, all right, it's like if I took my line segment here, so let's look at 3 different ways. Here's one, here's one, here's one. Okay. These all look the same, right? Here's a midpoint in terms of a point, all right? Here it is in terms of a line. And what's a plane? What is a plane? It's some type of flat surface. Like if I took a line and I stuck a sheet of paper through that line, all right, then that would be a midpoint, a plane. Now, all 3 of these go through the midpoint. All right. This, though, defines a segment bisector instead of just using the word midpoint. So any 3 of those things. Now, if you look at example 5, it says that B is between AC. It gives you BC, and it tells you the length of the whole thing. It then says to find the value of y and use that to determine if B is a bisector of that. In other words, take our line segment. Here's our line segment AC. So again, that's A. This is C. B is somewhere in between. For now, I'll just do it like this, and I'm going to put a question mark there. Put a question because I don't know if that's exactly where B is. All it tells me is that B is between the 2 numbers. All right, B could be all the way over here. Right? It could be all the way over here, or it may be here, or it may be somewhere close to that. It doesn't tell me where B is. It just tells me that B is between the 2 endpoints of the line segment AC. So AB is 2y plus 6. So here is AB is 2y plus 6. BC is y plus 8. And what other information is given to me? The whole thing is 20. Good. So the whole thing is 20. The whole thing means to do what with both of these segments? The whole means that I add them together. Good. So I'm going to add to that y plus 8. All of that has to equal 20. So now we're just going to simply go through and solve this. I know that I have 3y plus 14 is 20. Again, all I did is combine my 2y and my y and got 3y. And then the 6 and 8 and got 14. I'll subtract 14 and then do what? I have 3y plus 14 is 20, right? We just added 6 and 8. But I only want my y's. I'm trying to move everything away from my y's. So I subtracted 14 and had 3y is 6. What would be the last step? Divide by 3. So what's the value of y? Divide by 3. So I get that y is 2. And that's the first thing it said that we had to do. It says find y. What's the next part of it? To determine what?
B is a bisector.
If B is the bisector, good. So what I have to determine, in other words, is 2y plus 6 equal to y plus 8 if y is 2. So if I just check that. Y is 2, we established. So what does that give you for the length of segment AB?
2.
We put 2 in for y, so what do you get?
2.
We have 2 times 2 plus 6, right? Which is 10. Same thing here. 2 plus 8, which also is 10. Since they were the same, we want to write that B is a bisector of line segment AC. So B is the bisector of line segment AC. Now, if you'll take a look at example 6, on the back side of that. Example 6, 7, 8, and 9, they are all using the image that's been given to you. All right, so 6, 7, 8, and 9 are all using this image, this figure, in order to solve. Now, a key component to this is that WY, which is this one, let me change this. So WY here is a bisector of that point. Right? That highlighter doesn't work very good. Right. So WY bisects that point. So bisects it, again, means that it goes straight through the middle. So for example 6 and 7, I want you to go ahead and look at 6 and 7, and you can look at 8 and 9 too. So go ahead and look at those. I want you to use that figure along with our definition of a bisector in order to go through and solve those the best you can. And we'll talk about those here in just a second. All right, let's look at example 6. Now, again, the key component here is line segment WY bisects line segment UV at the point Y, meaning that this point Y is therefore the midpoint of the segment UV. So it says UY is 5. So U to Y is 5. So what's then find YV and UV. So YV is this. What's this line segment YV's length? 5. So what is line segment UV's length? 10. That was simple. There's no reason anyone should have had that problem blank when I just walked across the room. It's very simple, very straightforward to you what was asked and what was expected from that problem. Now on number 7, it says that, so we won't need the same information anymore. We can get rid of that part of it. Now we still know, it doesn't change the fact that Y is the midpoint of line segment UV. So example 7 says UY is 4x minus 3. So always go and label, or if you need to redraw the image here each time, you can. All right, so if I want to go back and I want to draw U and Y, that's 4x minus 3. Then it tells me that YV is x. It says find UY and find UV. So what am I going to do with those two things? What's true about that 4x minus 3 and that x? How are they related to each other? We have this length and this length. If y is the midpoint then what's true about these two lengths? They're the what? They're equal. Good. So 4x minus 3 has to be equal to x. And I now have a simple equation that I can solve here. So depending on you, it's up to you which method, or from here where you went, but I would have moved the 3 first. That made those go away. Then I'd want to move the x to the other side. So the x's go away. And I'm just left with 3x on the left and 3 on the right. So what would the value of x be? X is 1. But it told us to find the value of the line segment UY and UV. So what's UY? 1. I just plug the 1 in here for x. 4 times 1 is 4, minus 3 is 1. How about for YV? I'm sorry, yeah, YV is the value of x, so UV is 2. Because UV is the whole length. Right? UV is the whole length. We know this is 1 and this is 1. 1 and 1 gives us 2. All right. Now example 8, it gives us UV is 18. Right, so the whole length is 18. Remember we have U, V, Y's in the middle. So U, Y, V. It tells us that U to V is 18. U to Y is 9. What's Y to V have to be then? 9. It also has to be 9. And the last example there, if U to V is x plus 6. So again, let's look at what we've got here. We've got a segment, right? We're going from U to V. That whole length is x plus 6. U to Y is x minus 1. So remember, we still have Y, which is our midpoint. U to Y, so from here to here, is x minus 1. We are asked to find what the missing point is. All right, we're asked to find what is Y to V. So what is this length from here to here? How do I find that? Good. Subtract what from what?
X plus 6 minus x minus 1.
So we'll take our x plus 6. We'll subtract from that the whole thing, x minus 1. Now we're subtracting the whole thing away, right? So that's really the same thing as x plus 6 minus x minus a negative 1, which is a positive 1. So what happens to my x's? They cancel. That goes away with that one. Leaving 6 plus 1, which is 7. So 7 is our value from Y to V. Now again, an outline kind of how it's going to be the next few weeks. I'll be in here on Tuesdays and Thursdays. We'll do notes on Tuesdays and Thursdays. On Mondays, Wednesdays, and Fridays, you'll have the sub in here that you'll be doing assignments with. I'll keep the board updated up there. So again, today's Tuesday, 2.4 is due. Tomorrow, Wednesday, you'll work on the assignment I'm fixing to give you, and you're going to have the last 10 minutes in class to start working on the assignment that you'll have tomorrow. And then you'll get one other sheet tomorrow that has a few questions on it as well. On Thursday, we won't be here. So when you get here on Friday, your assignment that you get in class tomorrow will be due, and we'll be taking the test. Now, for the test, again, look over all of your notes, 2.1 through 2.5. All right, it covers Unit 2. And that test will take mostly the whole period on Friday. All right, so that's an outline for the rest of the week. Again, I don't know when Miss Barthold will be back. The stuff, now that I'm in here, I'll be getting your stuff graded as quickly as I can and figure out how we're going to get it in the grade book so you can have it all in there in a timely manner. All right.